let's think about the way that we chose to draw the objects when we were thinking about the object model for multiplication. If we wanted to model 5 times 3 equals 15, we would draw 3 objects, and then we would look at 5 copies of that. So 1, 2, 3, 4, 5. Notice how we chose to draw these. We didn't line them up end to end. Instead, we arranged them in 5 rows, 3 columns. So 5 rows, and then 3 objects, per row. This is going to give us an idea of how we want to extend our vector model to show us multiplication, and take advantage of the fact that each time we have 3 objects, it's the same 3 objects, not 3 one time and 7 another. Notice that we haven't just lined these objects up end to end. We've stacked them on top of each other. We're going to do the same thing with our vector model. We're not going to look at just one number line. We're going to look at 2 number lines at angles to one another. So again, we're going to look at a number line, and we're going to look at the vector 3. That's 3 units long, going to the right. And we're going to make 5 copies of this vector. But instead of stretching them out end to end, we're going to stack them one on top of each other. So 1, 2, 3, 4, 5. And now I want you to notice something. If we draw another number line going upward here, we'll see 0, 1, 2, 3, 4, 5. This is a rectangle, right? It has the vector 5 for its left side and the vector 3 for its bottom side. And now we're going to think of each of these little squares as a unit square. A square that's 1 unit on the side, we can think of that as a unit square. And we can look at this rectangle, and we can understand its area as the number of unit squares that it covers. Right? That's what it means to be the area of a figure. This rectangle is 3 units wide, 5 units high, and we can understand 5 times 3 to mean the area of this rectangle. You may have encountered the formula for a rectangle, area equals length times width, in the past. In a very real sense, that formula is just what it means to multiply 2 numbers together. To multiply 3 and 5 together is just to count the number of squares covered by a rectangle with width 3 and height 5. Now the cool thing about this is that this gives us a way to multiply large numbers. Let's see how. Let's say we want to multiply 187 by 93. Well, 187, that's just 100 plus 8 tens plus 7 ones. 93 is 9 tens plus 3 ones. This is called the expanded form of these numbers, just in case you want to think about how to refer to writing a number this way. That's just one digit followed by a bunch of zeros. Put them all together. That's the expanded form. So if we want to imagine a rectangle that's 187 wide, of course my page isn't really big enough to draw that, but I can kind of flub it, not to scale, but imagine we have 100, 8 tens, and 7 ones. Right, we take this rectangle that's 187 long, we break it up into a bit that's 100 long, a bit that's 80 long, and a bit that's 7 long. It's 93 high, we break it up into a bit that's 90 high, and a bit that's 3 high. Why would we want to do that, you ask? Well, numbers like this are easy to multiply together. Right, we just multiply the first digit. 1 times 9 is 9. And then we total up the number of zeros. We'll make this idea a little bit more formal later on, but hopefully this move is already familiar to you. 100 times 9 tens is 1 times 9 times 100 times 10, or 9,000. 80 times 90, 8 times 9 is 72. 10 times 10 is 100, so we have 2 zeros on the end. 7 times 9 is 63. 1 times 10 is just 10. We'll have 1 zero on the end. 1 times 3 is 3. 100 times 1 is just 100. So 2 zeros on the end. 8 times 3 is 24. 10 times 1 is just 10. So 1 zero on the end. And finally, 7 times 3 is 21. Now we can add all of these up. So 9,000, 7,200, 630, 300, 240, and the last one is 21. Add them all up. The only digit in this column is a 1. 3 and 4 is 7, and 2 is 9. 2 and 6 is 8, and 3 is 11, and 2 is 13. Write down the 3, carry the 1. 1 and 9 is 10, and 7 is 17. 17,391. Of course, this is not our usual method for doing multiplication, right? The standard algorithm for multiplication, though, follows the same pattern. Here, check it out. What do? We write 187 times 93. 3 times 7 is 21. Carry the 2, write down the 1. 3 times 8 is 24. Add in the 2, 5, 6, 26. 3 times 1 is 3, add in the 2, and that's 5. So notice what we did. 3 times 7 that's the 21. 3 times 8, that's the 24. 3 times 1, that's the 3. All right, now we're going to multiply 9 times 7 and get 63. And we're going to write the 3 in the tens place. Why? Check it out. 9 times 7, that's our 63. I'm going to cross off these old carries so we don't get lost. 63, write down the 3, carry the 6. 9 times 8, that's our 72. Add in the 6 at 78, carry the 7, write down the 8. 9 times 1, that's our 9. Add in the 7, that's 16. Add these together, 1, 9, 13, 7, 1. 17,391. Now, probably you've seen this method before. This is called the standard algorithm for multiplication. Of course, you are welcome to do this multiplication using a calculator because this process is a little bit tedious. There's one other process for doing multiplication that we would like to talk about, and that borrows actually more directly from this area model. The other method for doing multiplication that I want to mention is called the lattice method or the box method, and it looks like this. Very much like what we drew up above. We draw a box with 3 columns, one for each of our digits, 1, 8, 7, and 2 rows, one for each of our digits, 9, 3. Right? This is the same picture that we drew before, except that we're going to let the method take care of handling the zeros for us. I'm going to draw a diagonal line in each box to split up the tens place from the ones place. And just like I did up here, I'm going to go through and multiply every pair of digits. So 1 times 9, that's just 9. No tens, 9 ones. 8 times 9, that's 72. 7 times 9, that's 63. 1 times 3, that's just 3. 8 times 3, that's 24. 7 times 3, that's 21. And now we add up down the diagonals. Here we just have 1. Here we have 3, and 2 is 5, and 4 is 9. Here we have 6, and 2 is 8, and 2 is 10, and 3 is 13. So we write down the 3 and carry the 1. Here we have 1 and 7 is 8, and 9 is 17. Write down the 7, carry the 1. And here we have 1 and 0 is 1. So again we get reading down and to the right, 17,391. Same answer. Each of these 3 methods gives us the same answer. That's good, right? Any 2 correct ways of doing the same thing had better give you the same result. This again is called the lattice method. Depending on where you went to school, you will have learned the standard algorithm at some point, or the lattice method at some point, or maybe both. The reason I'm showing you both in this video is that I want to call your attention to the fact that both these methods for doing multiplication come out of this area model. Later on, when we're trying to multiply more complicated objects, like fractions, and later on more complicated algebraic objects, we're going to want to call back to this area model to see why we multiply the way that we do.